Welcome. Let's understand the idea of a logarithm function. We can think of a logarithm function as the inverse of an exponential function. Let's visualize this idea. Let's say that we have some value. Let's call it x. And this value, we're going to plug it in into some exponential function. And then as an outcome, we're going to get some value. Let's call it y. There exists a function called a logarithm where if we get this value of y and we plug it in into a logarithm function, the output is going to be the original value of x that we plug in into the exponential function. So how exactly can we write logarithm functions? So the following function, let's call it y. And instead of writing the whole word of logarithm, we just shortened it by calling it log. And this function is going to be made out of two parts. The first part is what we call a base, and we write it as a subscript right underneath the g. So let me write a b for the base. And the second part is the value that we are plugging in into the function. So we usually open a parenthesis, and that's where we plug in our value. Let's call it x. So we have defined a logarithm function as the inverse of an exponential. Then it is possible to write a logarithm function as an exponential. So let's show this by first writing a logarithm function. And if we wish to write this logarithm as an exponential, we can get the base of our logarithm and make it the base of our exponential. And now this exponential is going to be raised to what our equation was equal to. And then we're going to set it equal to the input of the logarithm function. So given any logarithm function, we can always perform this movement and rewrite it as an exponential. Now let's put this into practice. So we have a set of log functions. We would like to write them as exponentials. Let's start with example A. Let's identify the base of my logarithm, which is 4. Let me make it the base of my exponential. And now 4, let's raise it to what the equation was equal to, which is y. And this exponential is going to be equal to what we have inside the function, which is a variable of x. So we are done. Now let's look at example B. Let's start by finding the base of my logarithm, which is 7. Let's make 7 to be the base of my exponential. And now 7, we're going to raise it to what the equation was equal to, which is y. And now this exponential is going to be equal to what we had inside the function, which is a variable of x. So we are done. In example C, the base of my logarithm is 2. Our exponential is going to have a base of 2. And then we're going to raise that to what the equation was equal to, which is y. And now this exponential is going to be equal to what we had inside the function, which is a variable of x. Now, when we take a look at example D, notice that the base of the logarithm, it was not written. Anytime that the base of the logarithm, it's not written, we will assume that it is of a value of 10. 10, it is the standard value of a base of a logarithm. And now that we have identified our base, which is of a value of 10, now let's write this logarithm as an exponential. The base of the log, it is the base of the exponential. And now we're going to raise it to what the equation was equal to, which is y. And this exponential will be equal to what we had inside the function of log, which is the variable of x. So now we have written our logarithm as an exponential function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.